All right, I have here a data set of 100 students. So I have student 1 all the way down to student 100. So I have a data set of 100 students, and I've collected their heights, weights, ages, genders, whether they were full-time or part-time, and their race. And what I'm going to do today is I'm going to go ahead and create a normal quantile plot or a QQ plot to try to determine if some of these numerical values are being pulled from populations that are normally distributed. The one I'm actually going to look at today is I'm going to look to see if the weights of the women in my data set are taken from a normally distributed population. I'm trying to see if the weights of women here are normally distributed. So the first thing I'm going to do is I'm going to separate out the women from my data set. So I'm going to highlight the entire data set, highlight it all the way down, and then I'm going to come up to the tab up here that says sort, and I'm going to click that sort tab, and it's going to ask me, do I want to sort from A to Z, sort from Z to A, or do I want to do a custom sort? I'm going to select custom sort, and it comes up with this dialog box. And if you notice across the top, I have their labels: ID, height, weight, age. I can sort by any one of those labels. So what I'm going to do is I'm going to click this drop down box, and I'm going to sort my data by gender to separate the men from the women. So I'm going to sort by gender and click OK. And you see now the men and women are mixed in. You have male and female mixed in. Once I click OK, it separates it out in alphabetical order. So the females are all in the top of the data set. And then when you get to the 58th row, which would be the 57th person, um, you have males after that. All right, so we have 57 because the first row is just the labels, and the last row that has a female on it is the 58th row. So we have 57 females. Let's separate them out. So I'm going to highlight only the females now, which is from row 58 up. And I'm just going to copy this, copy, and create a new sheet by pressing this plus sign. And this second sheet is just going to consist of the data about the female students. So these are only the female students on this second page. So I'll actually rename this female tab. So the second tab has only the females. What I'm going to do is I am going to go ahead and see if the weights of these women come from a normally distributed population by creating a normal quantile plot. So first things first, I'm going to go ahead and I'm actually going to resort the data now. And instead of sorting it by um, gender like I did before, this time I'm going to sort by weight to put the weight in order from smallest to largest. So I'm going back to sort. I'm going to custom sort again, and this time instead of sorting by gender like I did before, I'm going to sort by weight, and that's going to put this the person with the smallest weight first, and the person with the largest weight last. So we'll sort by weight, okay, and okay. So here we have a 70-pound female, height 59, all the way up to 192-pound female. So we have our females' weights in order. In order. We have female weights in order now. Let us go ahead now and create a counting variable. So I'm going to create a counting variable to count up and see how many weights there are. We said there were 57. Let's make sure. So I'm going to call my counting variable I, and I'm just going to let I count all the way from 1 to whatever the number of females were in my sample. So 1, and then I go down and press 2. So I have 1 and 2 there, and then I'm just going to highlight those two and come over to the right here until my cursor turns into a plus sign, and then I'm going to drag that all the way down until I see the last row of entries. Drag it all the way down, and it goes all the way down and counts all the way up to 57. So now I have one column that represents counting from 1 to the last data value. The next thing I'm going to do is I'm going to try to divide up this space, these 57 things, into percentiles. In order to do that, I'm just going to take all 57 and divide them into equal blocks. And here's how I'm going to do that. This next column is going to be the value of I, which is just the counting variable, I, minus zero point 0.5, zero point 0.5, and then I'm going to take that and divide it by n. So divided by 57. That's what I'm going to do in this column here to create the percentile values, the areas. The areas. So let's go ahead and do that. This is going to be equal to. So I hit the equal sign and I put an equal in the cell right here. And it's going to be equal to, I'm going to open a parenthesis. I is in this column here. So I'm going to click that cell and it's going to say H2 because that's where the value of I is going to come from, and then minus zero point 0.5, minus zero point 0.5, close parenthesis, and then I'm going to divide that by the number of values. The reason I'm dividing by 57 is because there are 57 values. However many values there are in your data set, that's what you would be dividing by here. I'm dividing by 57 because I have 57 women in my sample. And I press enter, and there's the area. That's the percentile for the first woman's weight. That would be what the percentile value would be. And once again, I'm going to highlight. I'm going to go over here, sorry, until this thing turns to a plus sign. So I go to the lower right corner until the cursor turns to a plus. I'm going to drag that all the way down and find the percentile of all the values. So those would be the percentile values. I have the percentiles. Once I have those percentiles, the next thing I want to do is I want to create my theoretical distribution, my theoretical z distribution based on these percentiles right here. So I'm going to label that ZT for z theoretical. ZT for the theoretical z-scores, and these are going to be, this is going to be what I'm comparing my actual sample to. So this is the theoretical z-score. If I had 57 values and they were coming from a normally distributed population, these would be the z-scores I would expect for the individual values. So this is the theoretical distribution. So then this one is going to be equal to then, and I'm going to use the inverse normal distribution function from Excel. So I'm going to start typing NOR, and I have a bunch of normal distribution functions to select from. The one we're selecting is the normal standard inverse. It returns the inverse of the standard normal distribution. That's where my theoretical curve is going to come, or my theoretical values are going to come from. So I highlight this, and I'm going to find the inverse normal from a standard normal probability for this area right here, or this probability. So I'm going to highlight that cell right beside it with the percentile there. That's the percentile I want. Close the parenthesis, press enter, and this would be the z-score represented by this percentile. So if I had 57 values, I would expect the smallest value to have this z-score. I'm going to go ahead and I'm going to drag that all the way down, drag it all the way down. If I had 57 value, I would expect the largest value to have this z-score. So that's my theoretical z distribution. Now I'm going to calculate the actual z-scores from the ages, or sorry, not the ages, the weights. Now I'm going to calculate the actual z-scores based on the weights over here. So these are the Z actuals, the actual Z. I'll call that ZA, or the actual Z scores. In order to calculate the actual Z score, if you remember, the Z score should be the value minus the mean divided by the standard deviation. So that's exactly what I'm going to do. I'm going to write I'm going to type equal. So I type equal. So Excel knows I'm going to be typing in some arithmetic. And then I'm going to open a parenthesis. I'm going to select the value, the smallest weight here. I'm going to subtract from that the average weight. Well, to find the average weight, I'm going to use another function here. Excel has a function, average. I'm going to start typing average. And if you look now, this drop-down box, the second function, once you start typing average, is average. So you highlight that and it says returns the average or arithmetic mean of its arguments. So I double-click and it puts average in here. And it's asking me, what numbers do you want to find the average for? So I'm going to highlight all of the weights. I'm just going to scroll and highlight all of the weights, all the way down to the 57th weight. And you see now it's doing the average of cells C2 through C58. I'm going to put anchors in here so that doesn't move. So it always does C2 to C58. An anchor is just a dollar sign. So I put a dollar sign in front of the 2. And I'm going to also put a dollar sign in front of the 58 so that Excel doesn't go through and change those. and then I'm going to close that parenthesis for the average. I'm also going to close the parenthesis for the C minus the average. And then I'm going to divide this by the standard deviation. So divided by, and I'm going to start typing standard deviation, ST, and a bunch of functions start coming back. They have standardize, standard deviation P. This is the one we want, the standard deviation S. It returns the standard deviation based on a sample, which is what we have. So I double click that, and it's going to ask, what do I want to find the standard deviation of? I'm just going to go ahead once again and highlight the weights. Highlight all of the weights. So here I've highlighted the weights. And look again, it's going the standard deviation of cell C2. I'm going to anchor that to C58. I'm also going to anchor that 58 so that doesn't move when I drag it. All right, and then I'm going to close the parenthesis for the standard deviation. Press enter, and there it is. This would be the actual z-score for this weight. So I have that actual z-score, and then I'm just going to put my cursor here until it turns to a plus and drag that all the way down to calculate all of the z-scores. So these are all my z-scores. These are all my z-scores. All right, so once you have your theoretical z and your actual z, the next step is to create a scatter plot for these two columns. So I'm going to highlight both columns, the theoretical z and the actual z. Highlight both columns. And then I'm going to come up here to insert and go over to the chart wizards here. And the chart that I want is this one here, the XY scatter. So I hit that and it comes down with this drop down box. And I want this first one, this XY scatter. I click highlight, and here is my QQ plot. This is the actual QQ plot, the quantile plot. What we're going to do is we're going to compare this to a straight line. So I'm going to add a trend line in. I'm going to click on the blue dots, click on the data values. I'm actually going to right click. When you right click on the data values, the blue dots, you see that one of the options here is to add a trend line. If you add a trend line, you can add any kind of trend line you want. I'm adding a linear trend line. And there is my linear trend line going through my data. And what we're doing is we're comparing to see if the data kind of follows a straight line path, a straight trend line path. And this looks like this data is kind of scattered about the straight line path there randomly. So in my estimation, it would seem as though the weights of the women in this sample come from a normally distributed population. So this is for the weights of women. So I'm going to change my chart title to weights of women. And what I can conclude from this, from looking at this, and also you would have a histogram, but looking at this and the histogram, my conclusion would be that weights of women seem to be normally distributed. If you separate men and women and just look at the weights of women, it seems as though the weights of women are normally distributed. In my next video, we'll take a look at ages and see if they're normally distributed.